Greetings everyone. So far in this course, we have covered artificial intelligence, machine learning, and types of learning. Now in this section, we will delve into the fascinating world of deep learning, popularly termed as DL, a subset of machine learning inspired by the workings of the human brain. So let's get started by understanding what exactly deep learning is. As already covered in the earlier sections, deep learning sits within the broader field of AI as a subset of machine learning. So naturally, it aligns with the fundamental stages of the life cycle of the AI model, starting with data preparation to model building, training, and deployment. Now, the biggest question is, what sets deep learning apart from machine learning? The answer lies in the history of the reasons contributing to the origination of deep learning, or popularly termed as DL. DL came into existence as a solution to address the challenges associated with conventional machine learning techniques. The first challenge is ML's inability to deal with complex datasets. Traditional ML algorithms often require manual feature engineering, where domain experts handpick relevant features from the raw data for the models to get trained on. This process is time-consuming, labor-intensive, and may not capture the necessary patterns present in complex datasets. Also, conventional ML models have limited capacity to represent complex relationships within the data. They struggle to capture high-dimensional and non-linear patterns effectively, leading to subpar performance. To solve these problems, scientists developed a new technique known as deep learning, whose core structure is inspired by the human brain. To build a strong foundation of how deep learning works, let us walk through a facial recognition example. Imagine you have a set of drawings showing different facial expressions like smiling, frowning, and laughing. With traditional machine learning, you might teach a computer to recognize these emotions by pointing out specific features in each drawing. For example, you could say, when someone is smiling, their mouth goes up and their eyes might crinkle. Now let's say you have a big stack of photos showing multiple faces with different emotions. Instead of telling the computer what features to look for, you let the computer to look at lots and lots of photos and figure them out on its own. Over time, the computer learns that when someone is smiling, their mouth goes up and their eyes might crinkle without you having to explain it. Deep learning systems excel at processing vast amounts of data, recognizing patterns, and taking complex decisions. This ability to learn from data without explicit programming is what sets deep learning apart and make it a powerful tool in various applications. So, what exactly is deep learning? At its core, deep learning is a subset of machine learning that involves training artificial neural networks on vast amounts of data, and machine learning itself is a subset of artificial intelligence that involves the development of algorithms and models, as discussed in previous sections. Deep learning involves training artificial neural networks with its core structure inspired by human brain on extensive datasets. These networks can then make intelligent decisions without explicit programming. It's like teaching a computer to learn from experience. Now that we have understood how deep learning works, let's understand the core architecture that powers this technique. Just like the human brain, deep learning architecture consists of interconnected units called artificial neurons. These artificial neurons are organized into layers, forming a network analogous to the neural networks in our brains. In our brain, neurons communicate with each other through connection called synapses. Similarly, in deep learning models, artificial neurons exchange information through connections between them. These connections, like synapses, transmit signals and play a crucial role in the network's ability to learn and make decisions. Neural networks are the backbone of deep learning and consist of layers of interconnected nodes or neurons. But how do they work, and what role do layers like the input layer, hidden layers, and output layer play? Let's find out. At the forefront, we have the input layer responsible for receiving the initial data or input. Each node or neuron in this layer represents a feature or attribute of the input data. Think of it as the sensory receptors of a neural network, capturing the essence of information we want the network to process. As we move into the depth of the network, we encounter the hidden layers. There can be one or more hidden layers in the network. These layers are where the magic happens. Neurons in the hidden layers process the input data using weights and biases, transforming it through a series of mathematical operations. The hidden nature of these layers refers to the fact that they are not directly observable in the input or output. The network learns to extract relevant features autonomously. Culminating our journey through the layers, we reach the output layer. This layer produces the final result or prediction based on the processed information from the hidden layers. The number of nodes in the output layer depends on the nature of the task. It might represent different classes in a classification problem or numerical values in a regression task. As we delve into the intricacies of neural networks, it's essential to understand their role as the fundamental building blocks of deep learning. These networks, inspired by the structure of the human brain, consist of interconnected layers of artificial neurons. Each layer plays a crucial role, from receiving initial data through the input layer to producing final predictions at the output layer, with hidden layers processing and transforming information along the way. Now, as we grasp the architecture of neural networks, let's address a common question. What sets neural networks apart from deep learning? Deep learning and neural networks are often used interchangeably, which can lead to confusion. However, it's important to understand that deep in deep learning simply refers to the depth of the layers in the neural network. A neural network with more than 3 layers, including the input and output layers, is considered a deep learning algorithm. And a neural network with only 2 or 3 layers is typically referred to as a basic neural network. So, in summary, deep learning is a type of machine learning that uses artificial neural networks inspired by the human brain. These networks process large amount of data to make smart decisions without requiring explicit instructions. By mimicking how our brain works, deep learning helps solve complex problems in various areas. Now that we have a solid foundation in neural networks, we can delve into the use cases of deep learning in the real world. The next section will showcase how deep learning is revolutionizing various industries from image recognition and natural language processing to healthcare and beyond.